How, y'all know how limits work. Y'all realize that a function value and a limit value aren't the same thing. Well, this trig one right here is one of the key ones that you have to know for trig. The deal is, if you try to do it, you do sine of 0, which is 0, because you know your unit circle, and you get what? 0 over 0. If it wasn't an indeterminate form, it wouldn't be worth our time. But yeah, this is an indeterminate form. And it's 0 over 0. There's a lot of indeterminate forms, 7 or 8 of them, but this is the one that you're going to use most at the beginning of calculus, right there, 0 over 0. Well, the thing that you would do is you would factor it. Except, folks, you cannot factor out those thetas. Y'all know that, right? You were in my pre-calc class, you know you can't factor out those thetas. It's the sine of that theta. So somebody says, well, we can't factor out the thetas. You might try using a trig identity to rewrite it, but I will go ahead and tell you that's bad. All right, I won't even make you suffer through that and watch what happens. I'm going to go ahead and tell you what this equals. It equals 1. I know it equals 1. And I'm hoping you will memorize, learn long term that the sine of theta over theta, only when theta is approaching 0, equals 1. This is not true if theta is approaching pi over 2. It's not pi over 3. It's only true when theta is approaching 0. And it has to be in radians. All right? You have to be doing this in radians. And a lot of people just memorize that and they're happy. And to be honest, probably be enough. But I want to show you why it works. So here we go. We're going to do a little geometry. We're going to pretend we don't know it equals 1. We're going to do a little geometry. Okay. I want to draw a really perfect circle because I've got my yarn back here, but I don't want people who are going to watch the video having to wait for me to get my yarn out and draw a pretty circle. So I'll just ask, did anyone go and look up Richard Brodigan yesterday on the internet at least? Oh gosh.
I thought you taught us everything about Richard.
No, there's a lot of things that I can't say about Brodigan in class that I thought you might read and see. Good old Richard. Can't believe no one cared enough to find out about why. It's all right.
That was on my agenda for today.
Yeah. Yeah. I almost made a bad comment, but I'm not going to. I had somebody get upset. Okay. Now, so what I do is I'm just going to draw the first quadrant of the unit circle. Just the first quadrant. Go. Mark my point right there. Yeah, this takes too long to do for the video because people quit watching it. And since they shouldn't matter anyway, they're at home, right?
Sorry, Molly, I'm just kidding.
Oh, that was mean to Miss McNulty. McNulty, right?
Yeah.
Okay, first quadrant. What I'm going to do is we're going to, now y'all know this point on the unit circle is 1, 0. This point up here is 0, 1, because it's a unit circle. And y'all do know that on the unit circle, the points are cosine theta, comma, sine theta. 0 radians is right here, folks. That's 0 radians. So the sine of 0 radians is 0. The cosine of 0 radians is 1. Now, what I'm going to do, I'm going to go up here and I'm going to do these in different colors so we can talk about them. And I know that your professor in college may not draw his triangle just like that, but here's my theta. And what we're going to do is we're going to, eventually in a few minutes, we're going to have theta get smaller. All right? But for right now, do y'all agree you have a right triangle right there?
Yes, sir.
Okay. What I want to do is I want to find the area of that triangle. And it shouldn't be that hard. This point up here is the cosine theta, comma sine theta. Is everybody all right with that? That point's cosine theta, sine theta. Cosine is the x value, sine of theta is the y value. And if you look at that purple triangle, you know that the area of a triangle, that purple one, is 1/2 the what? Base times the height. What does the base equal? What is the distance from here to here equal in terms of theta? Yeah, it's x, right? Everybody agree that's cosine theta from here to here, because cosine theta is x. And that point right there is cosine theta, right? So that's cosine theta is the base, and what's the height? Sine theta. 1/2 cosine theta, sine theta. Now, I'm going to talk to you about the blue arc. The arc. Since a lot of y'all didn't like that on that last test, I want to talk about this blue arc. Put me a little like that. Notice we're talking about this arc shape right here, right? Doing it in blue. It's that arc. It's not a line connecting them, it's a curve. What we're talking about, since I did this in blue, I won't do this one in blue. We're talking about the area of that arc. Okay? Area of arc. Area of arc. And I hope someone in here knows the area of an arc formula.
Radius times radius.
Ooh. It's actually the radians divided by 2 times the radius squared. You gave me the arc length formula. Who did that? Hey, you learned something last time, right? Okay, think of the area of a circle. The area of a circle is pi r squared. When you go all the way around a circle, do you just go pi? No, you went how far?
2
pi. 2 pi divided by 2 makes what? Pi. So there's the area of the arc. Now, the good news is we know the radius, because if the circle has a radius of 1, what is the distance from here to here? 1. What's the distance from here to here? 1. And the radian value is our theta. So the arc, the area of the arc, is just simply theta over 2 times 1 squared. And that's the area of the arc.
Are you talking about like the sector? Like
Yeah, that sector of the circle right here.
Okay.
Very good. Yeah, this sector of the circle right here. Maybe that's what I should have said. Area of the sector. Arc's the length over there. You're right. I should have said area of the what? Sector. Area of sector. We'll correct that. There. Area of sector. Can't spell it, so. Now, so far so good. We're using some geometry skills. We'll do the green one. What we're going to do for the green one is we're going to come up from the tangent that touches the circle right there. And if it touches there, it's going to be vertical. It's going to be a vertical line, tangent, fair enough? And it's going to go up, and we're going to come out with this until they intersect. And we're going to get our green triangle. Now, is everyone okay that, and if you look, you can do 3 separate pictures if you wanted to, but I'm trying to do them all 3 inside of each other. See our area, see our green one? See our green one?
Yeah.
What is the area of the green one? It's 1/2 base times height. Yeah.
The base is 1.
The base is 1. Very good. What is the height? The height measures from here to here. There's the height. The base is 1. I'm going to give you a suggestion. Draw you a triangle separate than the picture with the information that you know now. Where you know the base is 1. Draw you your own little triangle right here. Don't make it a right triangle. Don't make it a isosceles triangle. It is right here. That is theta. That is 1. And we're looking for the height over there, right? Okay, tell me what the height equals in terms of theta.
Tangent?
Tangent, yes. The tangent of theta equals h over 1. This is the hard one to get. I'll admit it, this is the hard one to get because you just don't, you know. We were weak when we taught you earlier in life. Now, so the h is equal to what? Tangent theta. I'm not going to write tangent theta over here. I'm going to write sine theta over cosine theta. So I have my purple one, I have my blue one, and I have my green triangle. Purple, blue, green areas. As long as we stay in the first quadrant, what's true about the area of the purple, the area of the blue sector, and the area of the green triangle? What's true about those? Is there some kind of relationship between those?
Similar triangle.
Ah, the green one and the purple one are similar triangles. But what else about those similar triangles? Well, how about the purple one compared to the blue one compared to the green one as values of the areas? The areas are... It's okay, think. Take a moment. This is big stuff. Something obvious. What's true about the area of the purple, the area of the blue, and the area of the green?
Oh, they have tangent.
They're all the same,
Oh,
except they're not.
I mean, not tangent, theta.
they all have theta in them. They would all be the same if theta got really, really small, wouldn't they? But what would be true about the area of this purple one versus the area of the blue one versus the area of the green one? Which ones are smaller?
The purple one.
Okay, the purple one's the smallest.
Yeah. And then the blue one. And then the green one.
There you go. Now, you could say if theta got really, really small, they would almost be equal to each other, wouldn't they? Right? If the theta angle got really, really small, does everybody agree this purple line would get real close here? Green? Do I need to draw some really small triangles, or you got the idea? Okay. And that's the reason some teachers, when they do this, will put an equal sign in there. Less than or equal to. I just can't do that. Or just put a less than sign in there. But what's happened is we know that the purple triangle is always going to have a smaller area than that sector, which is always going to have a smaller area than the green one. Fair enough? Now, if you were to look at that formula, Miss Quarles, what would you say would make this formula easier is to do what? Multiply? Multiply everything by? If you multiply by half, that's going to make that a fourth, a fourth, and a fourth. Multiply everything by? 2. Get rid of the fractions. Multiply everything by 2. Cosine theta. Sine theta is still less than theta. Oh, wow. Just plain old theta. Less than sine theta over cosine theta. Multiply everything by 2. Now, I'm going to help you on the next one. I'm going to multiply everything by 1 over sine theta. I'm going to multiply by 1 over sine theta. Somebody says that's cosecant theta. Yeah, it's probably easier to think of it as 1 over sine theta. I'm going to multiply by what? 1 over sine theta. 1 over sine is going to make cosine theta less than theta over sine theta less than 1 over cosine theta. And someone tell me something you see that looks important. What part of that looks kind of important to you right now? Remember, what are we trying to prove? We're trying to prove this equals what? 1. Look over there and tell me what you got that's close to it.
The middle.
Yeah, theta over sine theta. And it turns out if I knew the number that this was, and I knew the number that this is, I would know this one has to be what? Right in, it has to be what? Between them. Now, if I told you this was a 1 and this was 100, would that help you very much? No. It's got to be between them, but they also need to be what? Really small. But notice, as theta gets smaller, these three are going to get closer and closer together, aren't they? Fair enough? Except somebody says, Mr. Evans, that's not what you're trying to prove. You're right, it's not. I'm going to take the reciprocal of it. But if I take the reciprocal of that one, I've got to take the reciprocal of this one. And I've got to take the reciprocal of this one. Took the reciprocals. Take reciprocals. Notice I did not put in the less than signs. Somebody tell me why. Why did I not put in the less than signs? They're going to become greater than signs. And I'm going to prove it to you. They will become greater than signs. Very important that you realize that when you do the reciprocals, those become greater than. All right, let me try proving that right here, or at least demonstrating it.
I thought it was only the negative reciprocal.
If you multiply by a negative both sides, you do change the signs also.
Okay.
But we just took the reciprocal. What's this? Does everybody no, we did not put a negative anywhere in there. We just took the what? Reciprocals. Does everybody agree that 5 is greater than 2? Take the reciprocal. 1/5, 1/2. Is 1/5 greater than 1/2? Yeah, you take the reciprocal of both sides, you have to change the direction of that sign. All right, got to change. And that's something that y'all, that's something you may not know. That's something we've got to show you. So far, so good. You're listening, you're learning. This is big time thinking, Mr. Shaw. All right. I get to this point, and here's what I want to do. I am going to take the limits of each one of these. I'm going to take the limit of this one. As theta approaches 0, I'm going to take the limit of this one as theta approaches 0. And I'm going to take the limit of this one as theta approaches 0. Now, the one on the right is pretty easy. What's cosine of 0?
1.
Does everybody agree cosine of 0 is 1?
Yes.
Now you know why I keep telling you you've got to know your unit circle if you plan on taking any higher level math courses. It's 1. And does everybody agree that it actually gets closer to 1 from numbers smaller than 1? Because cosine can never be bigger than what? 1. So yeah, it gets closer to 1, but it gets closer to 1 from the smaller number side. Not negative, but numbers smaller than 1. 0.999. 0.99999. So this does get closer to 1, but it gets closer to 1 from numbers what? Smaller than 1. Okay, what's the cosine of 0 here?
1.
And you get 1 over 1, which means this one gets closer to 1 also. But when he gets closer to 1, 1 over 0.999 is going to be what? A little bit bigger than 1. 1 over 0.999999 is still going to be what? A little bit bigger than 1. Because does everybody agree this is getting closer with 0.9, 0.99, 0.999? So this gets there from numbers a little bit bigger than 1. What does the value of this part stuck in the middle have to equal if this one's getting closer to 1 from numbers bigger than 1, this one's getting closer to 1 with numbers smaller than 1, what must be the value in the middle? 1. This,
Where are you getting the 999 stuff from? Like, where are you putting that in to determine whether it's...
okay, the cosine of 0.0001 radians is 0.999. Here's how I know that. Okay, you agree the cosine is 1. You agree the cosine is the x value, right? As you come down this arc and you get real close, you get like 0.999. You're going to get real close to what? 1. But the number is really smaller than 1, isn't it?
Yeah.
Does that help? So what I'm doing is I'm thinking, okay, as I get closer to theta being 0, the cosine equals 1 at 0. But when I get really close, it's just a little bit less than 1. So I just think of it being less than 1 as being what? 0.999. All right? Now, what you just brought up is kind of an interesting thing, because if you look at the unit circle, you can figure out this concept. If I get closer and closer here, does everybody agree the sine right here is about 0.999? And the cosine right here is probably about what? 0.00001, isn't it? If I get on this side, the cosine is going to be negative 0.0001. If you know your unit circle, you can do limits with trig functions, because you can see where you're getting closer to 0 and whether it's what? Positive or negative. Or if you're getting closer to 1.
You can just kind of use it to like check yourself.
That's what I'm always, yeah. Anytime you look, the unit circle is key to all the trig stuff that you do. Now, so we have proven this equals 1, and there's the proof. That's the proof for limit as theta approaches 0 of sine theta over theta equals 1. There's the proof. Yes, ma'am?
How did you just know to multiply it by 1 over sine theta?
Okay, now, all right, your question, that. Honestly, the reason I know to do that is because I've seen it before.
Ah,
The reason you will know how to do it in the future is you have seen it before. Now, imagine this. Imagine you've never seen it before. Imagine it's never been proven. The first person or the first people that proved it around the world, they had to come up with some formula here and some formula here to where they knew this one would always be between them. And then this had to be able to be rewritten as sine theta over theta. And what you had written here and here had to both get closer and closer to the same number. If this was getting closer and closer to 5, and this was getting closer and closer to negative 5, would that really tell you the answer was 1? Right, hear that? You know what I'm getting at? If I told you they were both getting closer to 1 from numbers smaller than 1, would that really help you? Yes, ma'am.
nothing.
No, come on, ask me.
No, it wasn't about math, I promise.
What was it about?
Nothing.
I want to know.
No.
Yeah, I do.
I don't think
Ask question.
It was about math, actually. I was talking about how wonderful sine theta is. See, you don't believe that either, do you?
No.
I don't either.
And I haven't been to law school and I can tell you're lying.
Yes.
Okay,
Neither have
ma'am?
I said neither have I.
But the whole deal is when you look at this formula, what makes it interesting is the first time that someone came up with it, the first couple tries, this didn't happen. Maybe the first 1,000 tries, this didn't happen. Because when you set up the relationship, it has to work out to where they get closer to the same number, and the relationship is always here. Okay? So yeah, this was not like a chump thing the first time it happened. First time it happened, this was a big deal. And the reason this was a big deal is you can't do much trig without this.
Mm-hmm.
Trig limits, you can't, all you would ever know would be cosine and sine, and you would never be able to do the nasty ones without this.